Dear students, last day I have teach you the first topic on the intermediate physics is electric charge, positive and negative charge, excess and deficiency of the electron. Now today I will discuss or I will teach you the conservation of the electric charge. As you know that the definition of the electric charge is this: when we have a glass rod and other is silk, then glass rod rub with silk, then they have equal and opposite charges. Can say glass rod have positive charge and the silk have negative charge, but the total charge is equal before rubbing the glass rod with silk or after glass rod rubbing with silk. They have equal and opposite charges, and finally the total charge is same. Suppose that glass rod have positive charge and silk have negative charge. After rubbing this condition, the glass rod have positive charge and silk have negative charge. Before rubbing the glass rod with silk, they are neutral. They will be neutral in its position, because glass rod have equal and opposite. Glass rod have equal number of proton and equal number of electron. Then this is finally neutral body, and silk have equal number of proton and equal number of electron, and finally it have neutral body. But when these are come in contact with each other, then they have positive charge and negative charge, and the final charge is conserved or final charge is equal or neutral before rubbing the glass rod with silk and after rubbing the glass rod with silk. It's another example is this. The electron is this. Suppose we have a electron particle and other is positron particle. Positron particle is an elementary particle. These are elementary particle, but the positron have equal and opposite charges to the in comparison of electron. It have negative charge, it have positive charge, but the final charge is 0 or neutral. When these are come in contact with each other, the final charge is 0 or neutral, and 2 gamma photons are produced and a large amount of the energy are produced. The final charge of or the total number of the charge, the electron and the positron have 0 or neutral. It is very easily understand with the help of, suppose we have 2 container. It have the number of balls are 10, and the other container is B, which have the same number of the ball are equal. It have 10, it have 10. The final number, if we transfer from 2 balls from here to there or 2 balls from here to there, or 2 electron from here to, the final number of the total number of the balls in the 2 container are equal before transfer of ball from one body to the another body. finally we can say easily charge is neither created or neither can be destroyed. It is just merely transfer of electron from one body to the another body, and the total number of the electron or total number of the charges in the two body or in the different types of the atom, the total number have equal before coming in contact with each other or after coming in contact with each other. Can say charge neither can be created or neither can be destroyed. And the next point is fundamental charge or quantization of charge. Fundamental charge. As you know that electron, proton, neutron, the elementary particle have the different types of the charges. As you know that very easily, the electron have negative charges, proton have positive charges, and neutron have neutral body. The different types of the elementary particle have different types of the charges on the basis of this smallest charge. This is on the basis if we just measure the charges of the different types of the ion or elementary particle, then it will be in the form of multiple. Or the elementary, if we measure the different types of the ion charges or the different types of the elementary particle charges we measure, then we have the charges will be in the form of multiple form. Can say suppose that we have, it is denoted by E, fundamental charge is denoted by E. Suppose that we have E charges and the other is 2E, multiple form, and other is 3, other is 4E. It is not on the form of partial form. Can say 0.5, 1.5, 2.5, 3.5. Charge cannot be divided in the form of partial form, or can say in the form of like as this, because charge cannot be divided in indefinite form. This types of the property of the charges is known as the atomicity of the electric charge or the quantization of the electric charge. The fundamental charge is this. The different types have the charges, the different types of the elementary particle or different types of particles have different types of the charge. This is the smallest charge. Neither charge can be smallest in comparison than this. This minimum quantity of the charges is known as fundamental charges. As we measure the different types of the charges, the different types of the elementary particle, then its charge will be in the form of the multiple form. This is known as fundamental charges, or the quantization of the charge the electron have. The charge will be in the form of the multiple form, E, 2E, 3, 4E, and not in the form of the partial form, or can say it cannot be divided in the indefinite form. This property of the electric charge is known as atomicity of the electric charge, or can say the quantization of the electric charge. As you know that Electron has negative charges and its value is 1.6 into 10 to the power minus 19. Because electron have negative charges, the sign is negative, and proton have positive charges, the sign is positive charges. Neutron have 0, and the alpha particle is the helium nucleus 2He4, and 2 into E, and 2 into 1.6 into 10 to the power minus 19, and 3.2 into 10 to the power minus 19 Coulomb. And the alpha particles have 3.2 into 10 to the power minus 19 Coulomb charge. Now the characteristic of electric charge. It is quantized. Electric charge is quantized. Quantized meaning its charge cannot be divided in the form of the indefinite form. It is divided. It can be only in the form of the multiple form, not in the form of the partial form, 0.5, 0.7, 1.5. It is quantized. It has additive in nature. Suppose that if you have a multiple number of the charges in a system, then the total number of charges is equal to the different types of the electric charge present in a system. It has a additive in nature. Q equals to Q1 plus Q2 plus Q3, and other charges is Q4 minus Q5. It is not depend upon mass and velocity. It is not depend on velocity. Its unit is Coulomb. 1E means the value of 1E. The fundamental charge value is 1 upon Now, next point is this Coulomb law. As you know that the like charges are repel each other and unlike charges are attracted each other. On the basis of this fact, Coulomb, who was the Francis scientist in 1785, he founded in his experiment he demonstrated that in his theory, suppose we have two charges Q1 and Q2 and separated at a small distance r. This is A point, this is B point. Suppose we have two charges situated at a different point and separated at a small distance r. Either these two charges have positive charge, either have unlike charges, or can say it have positive and it have negative, or either it have negative charges or either have positive charges. Then he found that in 1785, Francis scientist, if you have two charges Q1 and Q2 separated with a small distance r, then an electrostatic force work done between these two charges is directly proportional to the quantity, is directly proportional to the product of these two charges, and the inversely proportional to the distance square of the distance of these two particles. Can say F proportional to Q1 and F proportional to Q2. and F is also inversely proportional to the 1 upon r square. And finally we F equals to K Q1 Q2 upon r square. K is a proportionality constant. We write this. K is known as proportionality constant, which have value is 9 into 10 the power 9. If we measure F in Newton, Q1 Q2 in Coulomb and R in meter, then K value is 9.9 into 10 the power 9 Newton meter square per Coulomb square. K is proportionality constant. Its value for, or can say in the next topic, K is known as dielectric constant or dielectric substances. Its value for metals K equals to infinity, and its value for all other material is 0, and its value for air and vacuum for metal, for all other material. Its value for K equals to 1. Now finally Coulomb's found in his experiment, suppose if we have two like charges or two unlike charges, then the electrostatic force work done between these two different types of the charge either can be attractive or either can be repulsive based upon these two different types of the charge which separated at a small distance r. Then the electrostatic force work done between these two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance of the between two different types of the charge. F equals to 9 into 10 the power 9 Q1 Q2 upon r square Newton. If you have Q1 Q2 equals to 1 and r equals to 1, then F value is 9 into 10 the power 9 Newton. And the definition is this: 1 Coulomb charge is one which that when two similar charges are separate, when two similar charges, similar or different types of the charges are separated with a small distance r equals to 1, and then the force, the electrostatic force will be produced between or work done between two different types of the charge. Now finally the 1 Coulomb charge is one which repulses its similar charges to 9 into 10 the power, which repulses the similar charges 9 into 10 the power 9 Newton forces separated with a distance 1 meter. Now it's a smallest, the electric charge also have a smallest charge, smallest unit, which is microcoulomb. 1 microcoulomb equals to 10 the power minus 6 coulomb. Microcoulomb. Finally we can write one upon 4 pi epsilon naught also have value equal to the K. K equals to 1 for vacuum or air. Then F equals to 1 upon 4 pi epsilon naught Q1 Q2 upon r square Newton. And now I tell you about the epsilon naught. Epsilon naught is a new term which is epsilon naught. Its name is permittivity. It is permittivity of free space. Its value is 8.85 into 10 the power minus 12 Coulomb square per Newton meter square. Now we find the numerical value of the epsilon naught and the dimensional formula. Numerical value of epsilon naught and the dimensional formula. As we know that 1 upon 4 pi epsilon naught q1 q2 upon r square. We find the numerical value of epsilon naught. 1 upon 4 pi epsilon naught equals to 9 into 10 the power 9 Newton meter square per Coulomb square. Now epsilon naught value equals to 1 upon 9 into 10 the power 9 Newton meter square per Coulomb square into 4 pi 1 into 4 into 3 into 3.14 into 9 into 10 the power 9 this Newton meter per Coulomb square to the in uppercase Coulomb square per Newton meter square. Then finally we have its epsilon naught numerical value which asked in the examination. Now as we know that 1 upon 4 pi epsilon naught q1 q2 upon r square. Epsilon naught have q1 q2 upon 4 pi f r square. Q equals to it. 4 pi have no dimensional formula. F equals to ml t की power minus 2 l square. Then I square t square and it ml cube t की power minus 2 and finally a square t square ml m की power minus 1 l की power minus 3 t की power 4 a की power 2. Also its unit is meter second की power 4 ampere की power 2 its unit. As you know that we have k equals to 1 for vacuum or air, and now we have if we put in the place of vacuum or air we put the glass, rubber, plastic, paper, mica and its etc, some different types of the substances. If we put in the place of vacuum or air k equals to 1, then these all of these are insulator or these have nobody flow of electron. The current is not flow in these different types of the substances. These are insulated substances or specific inductive capacity. which is in a medium in place of vacuum or air. Then the value of, we know that F equals to 1 Q1 Q2 upon R square K. And for medium, for vacuum or air, and for medium 1 upon 4 pi epsilon naught K Q1 Q2 upon R square. Here the value of K, if you use the different types of the substances, glass, rubber, plastic, paper, mica, then its value is different for F. And it states that if we put some other types of the substances in a medium, glass, rubber, plastic, paper, mica, then the electric force will be decreased between these types of the charges. Can say if the first equation divided by second, first equation divide by second, F upon Fm, then we have 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and other is 1 upon 4 pi epsilon naught K Q1 Q2 upon R square. These are also cancelled, and finally we have K. These are in the uppercase. F upon the K is known as dielectric substances or specific inductive capacity, which have different value for glass, rubber, plastic, paper, mica. Its definition is that the ratio of the electrostatic force between the charges, dielectric substances within medium and without presence of the dielectric medium. Can say the dielectric substance is defined as the ratio of electrostatic force between these two charges when we have dielectric substance in a medium or without dielectric substances in a medium. Also, on the basis of these, we easily write epsilon upon epsilon naught. Here epsilon is permittivity of free space in a medium and permittivity of free space. And now the next point is the vector form of Coulomb's law. Vectors form of Coulomb law. Suppose Coulomb's law, as we know that the Coulomb's law is this. Suppose we have two charges. This point situated is A, the Q1 charge is this, and other is situated at a point B, and which is the Q2 charge. The force is in the direction of this, and the force is in the direction of this. This is Q1 charges, this is Q2 charges, and the force will be work done in the direction of this F12, and the force will be work done in this direction of this, and this is this is a unit vector which indicate which indicate the direction from q1 to q2. This also another unit vector which indicate the direction of q2 is from r2 to r1, here to there. Also known, this unit vector is also known as displacement vector. Displacement vector, because it displaces and give the direction of q1 to q2 or q2 to q1. Now we have force on q2 due to q1 is F21. Force on q2 due to q1 is F21, and the displacement vector or the distance or the unit vector is indicate from the direction of r2 to r1, and here we can easily write here direction, in this direction. Force on q2 due to q1. Force on q1 due to q2. F12 equals to this. F12 force on q1 due to q2. This is equation number 1, this is equation number 2. R12 and R21 are unit vector which is defined as this, or now on the basis of these unit vector, the first equation will be F21 equals to 1 upon 4 pi epsilon naught q1 q2 upon r cube r12, and it is also known as the third equation, which is first. On the basis of these two equations, R12 and R21, the second equation will be F12 equals to q1 q2 upon r cube r21. These two are the vector form of the Coulomb's law, which direction have slightly different from one another. Can say R12 equals to R21 direction, but it will be negative, or can say R21 equals to minus R12. This holds, we conclude that this holds the Newton's third law, because these two unit vector or these two displacement vector have the different direction with each other. Okay, and say finally we can say that the vector of Coulomb's law also holds the Newton's third law. Clear it? Now the next point is the force between multiple charges or principle of superposition. The force between multiple charges or superposition principle. As you know that it is very clear that on the heading of this force between multiple charges, suppose that we have in a system multiple number of charges, then and slightly these are separated with a small distance r, then the force work done between these different types of the charge are will be different. And finally we can say that if in a system a multiple number of charges situated or separated with a small distance r to one another, the resultant force F equals to the algebraic sum of the different types of the charge situated in a system. It is known as the force work done between the multiple charges or the superposition principle. How we can find this equation for superposition principle or multiple force between multiple charges? Suppose we have these types of the condition. If we have a multiple number of charges, can say q1, q2, q3 and after to n terms, and its point is O, center point is O, the force, as you know that we just studied in the previous section, in the previous topic, force on q1 due to q3, force on q1 due to q2 is F12, force on q1 due to q3 is F13, and force on q1 due to qn is Fn. Then the final or the resultant force is equal to the different types, algebraic sum of the different types of the force work done between these charges or in a system. This is known as superposition principle. Can say, suppose that if you have n multiple charges, n charges in a system, can say q1, q2, q3 and after to n terms, and the distance between to one another is r12, r13 and after to r1n, and the force work done between these different types of the charge F12, F13 and after to n terms. Then force on q1 due to q2, force on due to q2 is F12 1 upon 4 pi epsilon naught q1 q2 upon r12 ka square, r12 square, r21. Clear? And force on q1 due to q3 is F13, here is 1 upon 4 pi epsilon naught q1 q3 upon r13 square, r31. And force on q1 due to qn F1n equals to 1 upon 4 pi epsilon naught q1 qn r1n square, rn1 unit vector. And the final, the resultant force F equals to F12 plus F13 plus after to F1n. F equals to F12 value is here, q1 q2 upon r12 square, r21 plus 1 upon 4 pi epsilon naught r13 value, F13 value q1 q2 upon r13 square, r31 after 2 n terms, q1 qn r1n square, rn1. Clear is? And finally we have common this q1 q2 upon r12 square, r21 plus q1 q3 r13 square r31 plus q1 qn r1n square rn1. These are the resultant forces. And similarly, we can easily find that the next multiple charges for the different types of the charges is resultant force is F21 plus F23 plus after 2 F for second multiple charges 1 upon 4 pi epsilon naught Q2 Q1 upon R21 square R12 plus Q3 Q1 R31 square R13 and Qn Q1 upon Rn1 square R1n. This for F2. Complete it. It will be complete. It have complete the multiple charges or principle of superposition. Now the next topic is this, the comparison between the electric force and the gravitational force. Electric force is two types. Electric force, it will be attractive or repulsive, while the gravitational force is only attraction force, as you know that very easily. On the basis of these attraction force and the repulsion force, we have cleared that the charge have two types. On the basis of these attraction and the repulsion. On the basis of only attraction force, the mass is always only one types. It depend between medium of two charges. It depend on medium between two charges. It is not depend on the medium of mass. Between of mass. It is much more stronger than gravitational force. It is short range force or weak force in all types of the forces found in nature. Short range force or weak forces in all four types of the nature. If you have two protons, then the electric force is greater than 10 to the power 36 of gravitational forces. When the force is work done between two protons, while between of the electrons, two electrons, it will be more strong. I can say 10 the power 43 stronger than gravitational forces. 10 the power 36 times greater than gravitational force. The electric force 10 the power 36 times greater than gravitational force if work done between two protons. While in case of electron, it will be much more strong, or 10 the power 43 times greater than gravitational force. Now I stop it today's work, and the next topic will be start on the importance of the Coulomb's law in next day, or how we can charge to a body with the help of induction and with the help of conduction. I will just teach you in the next topic on next day